Welcome back for our next video on the series. This video we are going to be talking about implicit differentiation. So this is the first of several videos in which we will be talking about different applications of how to perform some differentiation. So implicit differentiation. Implicit differentiation can be performed in cases like these where it's difficult to find the derivative. Say if we were to do y squared equals 1 minus x squared, y equals plus or minus the square root of 1 minus x squared. It becomes difficult to evaluate the derivative for this, so there is a more direct way, I guess you could say. And that's by saying that if we have a function y of x, we can replace y with y of x. So we have x squared plus y of x squared equals 1. So now we just have to find the derivative. So what we're trying to find is the derivative. And if you remember from pre-calculus, this is the equation for a unit circle. So what we're going to be trying to do is trying to find the derivative of the unit circle. So we want to find the derivative of the unit circle with respect to x. So let's do that. So d dx of x squared is easy, it's just 2x. Now here's where we're going to run into problems. d dx of y of x squared. So this is actually simpler than it seems. All you have to do is apply the chain rule. Because if you remember, if we have d dx of f of u, that's equal to df du du dx. So if we want to apply this chain rule to this, we find the derivative of the outer shell, the function itself. So let's change y of x is equal, well, let's just say that y of x is equal to y. Let's forget that it's a function first. We have 2y. Now let's find the derivative of the shell itself. So we want to find the derivative of y of x. So in order to do that, we find dy dx. And then we know that the derivative of 1 is 0. So our new expression is 2x plus 2y dy dx equals 0. Now let's evaluate for dy dx. If we subtract both sides by 2x, we end up with 2y dy dx is equal to negative 2x. So dy dx equals negative x over y. So here we can find, this is the expression for the slope of a unit circle. Now let's just go through one other example involving a trig function. This one's going to be a little more difficult. So we have sine of xy equals 2x plus 5. So what we want to do is find the derivative of this function. The right hand side is easy, it's just 2. But the left hand side is slightly more difficult. What we want to do first is use the chain rule. And then we'll have to perform the chain rule again. So what we're going to be doing is finding the chain rule of, say that x, y equals xy is equal to u. So we want to find du of sine of u. And then we want to find du ddx, not ddu of xy. And we want to multiply those together. So ddu of sine of u is cosine u. So this is cosine xy. Now ddx of xy, if we, so this we have to perform a chain rule. dx of xy. So it's a combination of the chain rule and the product rule. Okay, so let's perform the product rule first. So we have dx of the derivative of x is 1 times the other part of the function, which is y, plus ddx of y times x plus x dy dx. Now the derivative of 1 is of y is 1 with respect to x times dy dx, if we remember from the chain rule. So this is what we have over here. So we can put these two terms together and we end up with the derivative of this function equaling the following. So we have cosine of xy times the derivative of the inside xy, which is y plus x dy dx equals 2. Now, once again, we're trying to find the value we were trying to evaluate for dy dx. So how do we do that? First, we have to divide by cosine of xy. So we end up with y plus x dy dx equals 2 over cosine of xy. Now we just have to evaluate for dy dx. So dy dx equals 2 over, we're going to be dividing by x cosine xy minus y over x. And there we have implicitly differentiated this function. So thank you for watching my brief video on implicit differentiation, and please come back for more as we go into our next video where we will be talking about optimization. Thank you for watching, and please subscribe, and I look forward to seeing you in our next video.